Hi, today we'll talk about asynchronous programming in Python. There are multiple ways we can do this depending on what we want to achieve. If we are aiming to uh, implement concurrent access in our application, then we should consider using asyncio. This is the de facto standard in Python for concurrent programming, and it is a high-level API which handles all of the concurrency issues for us. Concurrency is a problem in programming where multiple clients are trying to access the same resource, and thus the name. This library solves this by applying some kind of a wait uh, pattern, which means that it kind of implies that each client will need to wait for something, either for the other uh, client which is currently using the resource to finish, or for something else. This is the basic syntax of this of using this library. We run asyncio coroutines by using this run command. Coroutines are usually defined by using the async keyword or special word and putting it in front of the function definition. This function or this coroutine cannot be run in the normal manner. So if we didn't use this syntax, if we just wrote main, we would just get a reference to a coroutine. It wouldn't run. When we run a coroutine in this way, it will run in a safe manner, and it will execute its body, and we can include other coroutines inside of it as well. This is another built-in coroutine in asyncio for sleeping. Let's look at an example of this approach. So this is how the example looks. We have the main function, which is a normal regular function, and we use this asyncio run approach to run this coroutine. Coroutine sleep and print has two tasks. Tasks in asyncio are used to do some things in parallel, in addition to doing things concurrently. So concurrency and parallelism are different things. As we said, concurrency means that multiple clients are competing for a single resource, whereas parallelism means that multiple clients are utilizing multiple resources at the same time. So what this means is that these two tasks will run at the same time, and the second task, if we start them at the same time, then the second task will complete 1 second later than the first one. If we didn't create tasks out of it, if we just ran them as simple coroutines, then they would complete sequentially, and this one, the second one, would complete 4 seconds later than the first one. When we use the await keyword, we can await for a task, or we can await for a coroutine. So let's try running this to see what we get. Oh, okay, let's run this one. So let's see what just happened here. At 2 seconds, we see that it's starting execution. Then at 5 seconds, so 3 seconds later. Okay, so if it's starting execution, then it's running the coroutine at the same time. And let's see what happens with the coroutine. We are creating one task, second task, and then we are awaiting task 1. So first print and second print are happening. They are gonna happen only after this task finishes. So the first one happens 3 seconds after the beginning of the program. It's because we gave a delay of 3 seconds here to this function, and what it does is it will sleep for the specified number of seconds, and then it will log the provided text to the console. So this one will wait for 3 seconds and then log this, which we can see happens here. Then this is printed. I added this so we can see when the first task finishes. We can see it happens at the same time as the first print of the first task, and then 1 second after, second print happens, and then main function is finished, and only then do we get the result back, which is not what we would want to do if we want to do real asynchronous programming. So let's see what happens if we don't create a task. Let's just comment this out, and here we're gonna wait for this, and here we're gonna wait for that. I didn't try this before, but I'm expecting it's gonna run sequentially. Let's see. As we can see, now there is a 4-second gap between the end of the first task oh, okay, so let me see. There are 2 first prints. Oh, because I didn't change this. Okay, let's see one now. Right. So now we can see first print happens 3 seconds after the start. Then we see this in between. And then the second print happens 4 seconds after the first print, compared to the previous version where it happened only 1 second later. So we can use tasks to do things in parallel in a safe way. So in a concurrent and parallel way. But this approach, I wasn't able to figure out if it can actually not hang, if it can return the result and then perform these tasks in a real asynchronous way. So I don't think we can use this approach for our use case, where we want to return a result to a network client and then perform some processing in the background. second approach to asynchronous work in Python is threading. Threading actually is used mostly for parallel processing. It doesn't seem to do things asynchronously in Python. Uh, so let's see how threading example looks here. So it's pretty straightforward. We have also the main function, and we use the threading module and its thread object, and create a thread object with a specified target of this function. So this is now these are now regular functions. They are not coroutines anymore. We are just doing pure threading here, and we can see that what we are trying to check is if this will return before this is printed. So let's see what happens. So you can see it's starting execution at 48 seconds. Sleep and print finished only after 3 seconds, and then it says main function is finished at the same time, and it returns the result at the same time. So the result is not returned immediately in this scenario, and threading could be useful for doing parallel programming, but I think even for that purpose asyncio beats it, because asyncio also handles concurrency in a safe way, whereas with the threading library I'm not so sure about it. So I definitely advise of using this approach if we want to do something in parallel. And finally, the approach that I found that matches our use case the most is using futures. Futures, it's in the module concurrent.futures, which implies that it's a module used to handle concurrent programming. So multiple clients trying to access one resource, and here we use executors. We can see that so there is a thread pool executor and a process pool executor. I'm not in favor of any of them. You can use either thread pool executor or process pool executor. I used thread pool executor, and it worked pretty well. So here we have this syntax of with thread pool executor and its arguments as executor, and then we do stuff, and then the with block will handle resource release after we are done doing our processing. But I found out that this syntax will also cause some trouble for us. So let's see the code example. So this is the third example, test futures, and let's look at what we do here. So in all examples we are calling the main function here, and we are in the same time printing the result. So we can see in the main function we are creating an executor object, which is a thread pool executor from the concurrent.futures module, and this executor receives a parameter which is max workers. Max workers is cannot be 0, it can be none, and in that case it will automatically assign the number of workers. we can also specify a number of our liking. I think that 10, 8 or 10 would be an okay number. Even 2 is okay if we don't plan to do anything in parallel, if we just want to do asynchronous calls. So this executor we use it to submit a job, and our job in this case is going to be this function. So note that this is just the function name, we don't include the parentheses in the end, so it's just a reference to the function name. And so it will what this function will do is it will sleep for 3 seconds and then it will log its result. And after we submit the job to the executor, we get this future object, which is actually going to tell us it's going to tell us when the job is done processing. And after we're done processing the job, after the job finishes, we need to shut down the executor, and this is the part that I mentioned where the with block will not do, because with block will call the shutdown function with the wait parameter equal to true, which means that it will wait until the job shuts down, which means that we cannot return the response to the user before the job finishes. So here we specify shutdown, but we say wait equals false. So it will not wait, it will just shut down once the job is done, asynchronously, without us needing to do anything. So let's see how this runs. Okay, so we can see starting execution happened at 58 seconds. Main function finished with future happened at the same time, and the result was returned at the same time. So no hanging here. Then we can see that later on sleep and print finished was printed, which means that this was running totally asynchronously, which is what we need for this use case. So let's see what happens if we specify the wait as true. So we can see that now result is returned 3 seconds later than the beginning of the program. So we need to make sure that wait equals false on the shutdown command. Also, if we try waiting for the future result here, the same thing will happen, because this is kind of a the future object seems to be a channel which is going to wait until something is put on this channel, which will happen only after the job that we submitted finishes. So we can see that result is now returned 3 seconds after the beginning of the program. So we also shouldn't await for the result of the future. In this thread, we could try to process this future asynchronously in some way, but I think in our use case it will not be needed, because we are going to do some processing in the background, and the result of this processing will not be needed in this handler function. So let's consider this is a handler function in the app. It will just dispatch an async job which will process some things which take a long time to process, and it will just return the user a response which says your job was submitted for processing. Please try in a few seconds or something. And then the job will finish. It will put the things in the DB, and then when user later on tries to access this data, they will be able to do that. So I think this covers the use case that we want to achieve. I did not test the performance of this approach. I think you can try to apply it, and then we can see if it performs well. So please let me know if this makes sense, if this is clear, and we can discuss all the details in a meeting later.